The last factor affecting solubility that we will mention briefly is temperature effects. So I mentioned earlier that if we take a solution, say a saturated solution, we want to get more into it. If we heat the solution up, we can generally dissolve more solute into the solvent. And that is because of these temperature effects. So temperature effects are kind of described as follows. The solubility of most solids increases with increasing temperature, while the solubility of all gases decreases with increasing temperature. So we can illustrate that in a couple graphs. So here, if we've got a number of different ionic species, sodium nitrate, calcium chloride, lead nitrate, potassium nitrate, sodium and potassium chloride, and some other ones here, what we'll notice is that their solubility at 0 degrees varies depending on the identity of the ionic solid, which makes sense. But as we increase the temperature, for almost all of these cases, the solubility increases. Now, in some cases, it increases dramatically. For other cases, like sodium chloride, it doesn't increase that significantly. And that depends on the identity of the gas and some factors that are maybe a little bit beyond the scope of this particular course. And you can even see that for some rare cases, here we've got cerium sulfate. For some rare cases, the solubility actually decreases with increasing temperature. But for most solids, the solubility will increase with increasing temperature. Gases, on the other hand, for all of them, the solubility decreases with increasing temperature. Now, how do we rationalize that? Why is it different for gases than it is for solids? Well, for solids, remember, one of the things that we have to overcome is those solute-solute interactions. We have to break apart the ionic bonds. If we put more energy in the form of heat into the system, and remember, temperature is a measure of kinetic energy. So if we put more kinetic energy into the system, then we just have more energy to overcome those ionic interactions and break the solute apart from each other. For a gas, however, we're not dissociating the gas molecules or anything like that. We're trying to take those gas molecules and dissolve them into a liquid. And remember, when we were talking about partial pressure, that if you increase the temperature, you give more molecules the ability to escape from the solvent, and you generally increase the partial pressure over a liquid by increasing the temperature. And the same thing occurs here. If you give those gas molecules more kinetic energy, then when they hit the surface of that liquid, more of them are going to escape. And so you will increase the partial pressure, but you will decrease the amount that's dissolved in the solid. And so we see it depends here on the identity of the gas, how significant this effect is. But for all gases, the solubility decreases as we increase the temperature.